Okay, so we're going to walk through some solutions to isUnique. All right. So, all right, implement an algorithm to determine if a string has all unique characters. Okay, extra credit, answer this question. What if you cannot use additional data structures? And so what it means by data structures is like, can you solve it without having to like use another array, like to fill things up? I guess keeping a constant memory, like complexity. And let's see, with your class, have we gone over time complexity with your class yet? Okay, we haven't gone over that yet. So we'll be covering it. Essentially, it's when we'll get into analyzing algorithms, and something that we'll be looking at is how does the algorithm scale as, and when I say algorithm, that just means like function, just like an algorithm is just a fancy term for like your code, pretty much, just like solving something. And so, so complexity analysis is when we get into, how does the function scale? So as the input size increases, does it take, like, so if you double the input size, so if the array coming in is twice as long or the string is twice as long, does the function take twice as long to run? Does it take 1.5 times as long to run? Does it take 150 times longer to run? And so anyway, so we'll get into complexity analysis where you're looking at these functions and you're thinking, okay, how does this scale? How does it affect the function? And so you're going to get a little bit of an introduction into that today, and then when we get into data structures, we'll be hitting it pretty hard. I'm going over a lot of stuff to do with complexity analysis. So anyway, it's just a way of saying, like, is this function good? Can we make it better, etc. So yeah, same as big O notation. Yep. Yeah, so big O notation is what we're going to go over. And so again, like, don't worry about, we haven't covered it yet, so there's no expectation for you to know it, but you'll get kind of an introduction with this problem. So this is a solution 2 that I'm going to walk over with you guys in a little bit, but we're going to code out another solution right now. So, all right, so we need to determine, okay, so we need to determine if all characters are unique within the string. So this first one should be true. The second one should be false. Okay. So when you're solving these problems, the first thing you should do is identify some different test cases. And I've done that for you here, but in the future you won't have that. And you should identify it and think, okay, this input should give this output. This input should give this output. You should think that's the first thing you should identify is like, given this input, this is the output I expect. And once you have that down, then you know like what your problem is supposed to do. The next step is I would take some time to, or try to mentally solve the problem before you convert it to code. So try to like write out the instructions or the steps that you would take to solve the problem in like pseudocode. And what that means is just kind of like write out like in notes how you would solve the problem and then convert it into code. And so by doing that, you don't just start writing code and then like you kind of code yourself into a corner sometimes, and it gets hard to think about how to solve the problem. And anyway, it's the last step of writing your code should be the easiest step, because you should know the problem, know how to solve it, and then write your code. So when you're first starting out, that's hard to do sometimes, and so you'll have to like write your code and experiment to make sure that your syntax is yes. Anyway, so that's a little harder to do at the beginning, but that's where you want to get to. Right now, all right, so isUnique. And so kind of, you can ignore this code again, it's down below. So, all right, so the first solution that I could think of is, all right, let's, we'll iterate over the array, so, or the string, so iterate over the string. And then inside of that loop, so iterate is just means like looping or a for loop. So we're iterating over the string, and then we need to iterate over the remaining portion of the string and look. Oh, to say, okay, so we're gonna do like a nested for loop, and then in here we're gonna say do characters match. And then we'll say like if yes, turn false. And then at the very end, after the for loop finishes, we'll just say return true. So if we never find a condition where we return true, then I should put this on that line right there. So I'm just going to iterate over the string, and then I'll kick off another for loop. So with this string down here, A, B, C, D, essentially what's going to happen is I'm going to start on A, and then I'm going to go, all right, is B equal to A? Is C equal to A? Is D equal to A? Is H equal to A? Is I equal to J, et cetera, down to the end. And then if I don't find where they're equal, then I'll go to the next one. So is B equal to C? Is B equal to D? Is B equal to H, et cetera. So I'll just kind of walk through, do nested for loops. So const is unique. We'll have the string. And then we're going to go for, let I get 0, I less than string.length equals plus. And then inside of it, so that's iterating over the string. And now we're going to iterate over the remaining portion of the string. So for let j get I plus 1, j less than string.length, j plus plus. Okay, so we're starting just right after I. So wherever the I marker is, we're going to start one after and then check the rest of the string. All right, and then do the characters match? If yes, return false. So if stri equals strj, return false. And down here we're going to say return true. All right, so we just go over the string, and then from the inside we iterate over the rest of the string, and then we return false. If we ever find a match, if we never find a match ever, that means that none of the characters match, and then we can return true. And this right here actually satisfies the extra credit part where this does not use any other data structures. And so this, so this doesn't, it's all doing this in place. So, so it can be good in that regard. It's not going to, it's not going to eat up more memory because we're not creating another array to store the ones we've already checked or an object or anything like that. So it's not filling up any more storage, but time-wise, this function right here is going to, time-wise, this function is actually one of the worst ways that you could actually write something like this. So there's other more advanced ways you could write this, and we'll get into that in the future. But right now, I'm gonna, oh, let's do this. I'm gonna go copy this into the Chrome console. Well, or just in here, this works. So I'll paste the code right there. All right, so there's our isUnique function. And we'll say console.log the result of calling isUnique with A, B, C, D, F, G, H, I, J. Okay, so that right there should be and space and okay, so this should all be unique. So true. Okay. So now inside of it, I'm just going to add another star at the end. And it's false. So it detects that they're not unique. Okay. So this right here is actually one of the worst ways you can write a function, nested for loops. Because what this means, the two for loops, it means that, so if you think of the for loops as they're iterating over the string and the number of checks, when you have nested for loops, it's, well, we'll be going into this more detail later, but essentially with a for loop, if you think of just a for loop, as you increase the length of the for loop, the number of cycles in the function, the number of iterations is going to increase by 1. So if you have an array of 10 items, if you increase it by 1, then the loop is going to run 11 times. If you have nested for loops, and at least with this, we don't have to iterate over the entire string, so it's not quite this bad, but if this second for loop had to iterate over the entire string, so if it started at 0 and then went along, this function would be what's called a quadratic complexity. And again, we'll go into a lot of the details of this, but essentially it means that if we have 5 items in our array, it's going to loop 25 times. If we add a 6th item, instead of just looping 6 times or one more time, it's going to loop 36 times. If we had 7, it's going to be 49 times. If we had 8, it's going to be 64. So if I'm doing that math right off the top of my head, but like, or like 10 will be 100 times. So that's like, I guess that's where you can think of it. So if you had a single for loop that's just going to iterate over an array, and the array has 9 characters in it, it's going to loop 9 times. If you have a nested for loop inside of it that also iterates over it from start to finish, then you're going to have it go 81 times. If you increase the length of the array from 9 to 10, then one for loop is going to iterate 10 times, and then 2 nested for loops is going to iterate 100 times. So it's jumping from 81 all the way up to 100 by increasing the length by 1. So like if we were, again, like to kind of, let me just demonstrate that real quick. So const array is equal to right there. And then if I say const foo is equal to this function. All right, so in foo, it's just going to go for, let I get 0, I less than array length, I plus plus. So this right here, if I comment this out, so we have an array with 9 items in it. As this runs over the array, it's just going to iterate over it once. It's going to loop 9 times. If we if I do this, const bar equals array, and for let j at 0, j less than. So if we did that, this second bar, if we were to call it with array, so foo is going to run 9 times. This one is going to be, so for every time it runs, it's going to be going across 9 times, and then at each stop, it's going to iterate 9 times. And so it kind of makes like a square. You can kind of think about it. And so 9 squared, so 9 times 9, that's how many times this is going to run. If I increase, so at 9, this is going to run 81 times. So and then with 9, this is going to run, it's going to loop 9 times. As I increase this to 10, this one is going to go 10 times. So it's just going to loop one more time. Whereas this one, it increases to 100. So this one is just one more loop that's going to run. With this one, we have 19 more loops that are going to run by increasing the size only by 1. So we increase the array just by a little bit, a tiny little bit, and this function is all of a sudden going to take significantly longer. So essentially, it's a 25% roughly increase over 81. So like this one increases, the time it takes to run it increases roughly by like 25%. Whereas this one was, 1/9, like whatever that percentage is increase. So anyway, so if that kind of makes sense, this is the main idea behind complexity analysis. And this one doesn't quite loop, like it's not quite x squared, but it's still pretty bad at anyway, and we're going to go into this in a lot of detail later, so I don't want to confuse you guys too much on that right now. But it's just that this idea that there are potentially better solutions. And so I'm going to show you a different solution now. This one ignores the constraints for memory. And so this one, it makes use of a new ES6 data structure. So inside of ES6, now there is a thing we can use called a set. So just like arrays and objects, it's a new thing that's built into JavaScript that we can use now. And so arrays are, they're ordered. There's a bunch of values in them. Objects, like in an array, you can have duplicate values. It doesn't matter. You can have an array full of 100 5s. With an object, you have key value pairs. The keys are supposed to be unique. The keys are required to be unique on an object. And so you can't have duplicate keys on an object. And then it's just like that key value idea. So arrays, objects, and so a set is similar to an object, but it does not have a key value pair. It's just the value, but the values have to be unique. So if we come in here, I'm going to say const set is equal to new set, like that. That's how you create one. There's my set. And then I can go set.add, and I'll add a 5 to it. I'll say set.add a 10. Set.add true. Set.add an array. Okay, so my set, it can store any kind of values in it, but if I try to add like another 5 to it, it doesn't add it. So the values have to be unique inside of it. I think this will, so this right here, sorry, I gotta stuff's cut off. So you might think, oh, it's a duplicate array. So it's actually 2 different arrays in memory. And so that's why this works. They're 2 separate arrays. You can't have the same exact array that's in memory added twice to the set, but you can have 2 different arrays. They're different arrays, different entities in memory. So, and again, if that's confusing, we'll be going over that in a lot of detail later as well. So you'll thoroughly understand memory and objects and how all that stuff works. But all right, so this is a set, and so we can use a set to check for uniqueness. And so the way that we do it, so we create a set is the first step. So we create our string set, and then we iterate over the string. So let I get 0, I less than string.length, I plus plus, and then we say, is the character in the string already in the set? So if it is, so that's what has does. Has returns true if a set contains a value. So if I do const set is equal to set that, I do set.add 5, set.add 7. Now if I do set.has 7, that'll be true. Set.has 55 is false. Set.has some string, false. So it just tells you if it's inside of the set. So if this returns true, if the character's already in there, that means we've already seen it before, and so we're going to return false. If it's not in the set, we add it to the set. And so as we iterate through, we can add characters to the set, and then if we've seen them before, then we just get rid of them. And so anyway, the sets are pretty simple, and this is a use case for them for checking for duplicate values. And so anyway, this is one way you can do it. So here's 2 different approaches. Another efficient approach, if you wanted to do, so for example, if you wanted to do like this type of in-memory approach, but then making it efficient, if you have an efficient sorting algorithm, and we'll be going into that later, but you can have sorting algorithms that are fairly fast, and so you can sort it and then do a linear operation, but so you get away from the whole quadratic complexity, or you're not close to the quadratic anymore. But anyway, we'll give you the tools to understand that and work with those terms in the future. Okay. You guys have any questions about this? Sorry, I haven't been looking at Slack. Explaining again the relationship between the first for loop and the second for loop. Sorry, that was for 10 minutes. That was from 10 minutes ago. Okay. Any questions about? I'll give you guys a moment to finish typing. So 2 arrays inside the set. So, all right, let's talk about this real quick. This is just good to go over. So objects and arrays are passed by reference. And so what that means, if I do const x is equal to this object, and then so I have that defined, and then if I say const y is equal to x, if I do y dot some prop is equal to high, so I added that onto y. Now if I look at x, we actually see that some prop was added to x as well, and then y is the same. And so what happened, x and y are both variables pointing to the same object. So sorry, I'm on a touchpad, but So if like this right here is one reference, like that's the X and Y, there's one object in memory, and X is a reference to it, and Y is now a reference to it. They're a reference to the same object. So objects are not copied by default when you do this assignment. Strings and numbers are. Strings and numbers are, they get duplicated in memory, but arrays don't, and objects don't. And so that's why when you added that array to the set, when we do the brackets in line like that, what it's doing is it's creating an array right there. And so there were two separate arrays in memory that we were adding to the set. So anyway, this can be the source of some interesting bugs in your code if you're not aware of this. But objects and arrays are passed by reference, not by value. So let me, let's see. All right, so like for example, so if I had X and Y, so now if I do const set is equal to new set like that. Oh, that's why we took part in this. Okay, so const set2 is equal to new set. If you refresh your page, it clears this out, so then your consts don't step on each other. But so if I do set2 dot add X, all right, and then if I do set2 dot add Y, so you see it did not duplicate the object inside of the set. So the set, set2, set has just this object with some prop, like that's the only thing in there. It did not add a second one. Whereas if I did set2 dot add and then just typed in curly braces like that, it's creating a new object in memory. And so now we see that the set has our object with some prop on it and then this object in there. So they're different objects in memory. They're occupying two different locations. So like this would be our one that has like, you know, this like some prop would be like here. And then this is another object in memory right here. So it allows for, you can have different objects in the set. You just can't have the same exact object in the set. So a slight distinction there. And this is getting into some pretty advanced, pretty cool stuff with the language. And this will influence your thinking when we get to data structures. And that's something that will play a really big part when we do that. Okay. So as array tends to go, I mean, we've set out two arrays inside the set. Same array will not be allowed. Okay, same set. Okay. All right. Did that answer your question, Alan? So for those of you who don't know, Alan's kind of auditing the full-time class right now. He was doing the part-time, but he's been going super fast with it, and we might switch Alan into the full-time class. So. Okay, so that right there, if you're defining it in line like that, that will actually not, so I'm going to say const set3 is equal to new set, so I'll just make a new set. So if I do set3 dot add, and if I do hi like that, and then if I do, so I do set3 dot add hi again, so it adds them. So the contents of the arrays can be exactly identical, but they're two separate arrays. And it's because we're generating the array right here on that line. So we've created two arrays in memory. They have the same contents, but they're two separate arrays occupying two distinct spots in memory. And so because of that, they can be added to the set. If I did const, well, it's not gonna let me. Okay, so if I did const array1 is equal to hi like this, and then if I said const array2 is equal to array1, so right there, array2 and array1 are equal. So I think this might actually, so this right here will actually say true. Usually, so equality only checks if, when like equality with arrays and objects, it's not checking the contents of the arrays. It's literally checking to see if they are the exact same array in memory. And so this right here is saying, okay, array1 and array2 are the same. Whereas if I did, pretty sure this is going to say false. Yeah, so this is false. So interesting. This is kind of interesting. So this right here is false, but this right here is true because array 2, the variable array 2 and the variable array 1 are both pointing to the same array in memory. So when you create an array like this, it's created in memory. But then when we do this, it's not checking contents, it's checking to see if they are the same array. Because right here, this syntax, what it's doing, this creates an array in memory with a string high in it. And then right here, this creates another array in memory with a string high in it. And so they're occupying two different spots. So right here, in this example, like there and there, again, this is saying, you know, this, all right, we'll say the triangles are the references. I'm sorry, I'm doing this with the trackpad. So what it is we said this is equal to this, and then we assigned this to that, which in essence just assigns it to this. So we have these the two references that are assigned to this one object. That's example 1. Down here for the second one, what we're doing is we're saying, okay, create an object in memory. So when I say object in memory, arrays and strings and numbers and you know, functions, they're in JavaScript, they're all actually objects. Everything is an object pretty much in JavaScript. Don't let that confuse you, but we'll go into that in a little more detail. But so when I say an object in memory, that's a little more general of a term, but it's an array. So we're creating an array object, an array in memory that has the string high in it. And then right here, we're saying, is it equal to, and then we generate another one. That's what the syntax does. This right here, when you do the open and closing bracket, that's saying to the computer, create a new array. And so we're saying, all right, are these two arrays equal? Or are they the same? And they're not. Their contents are the same, but that's not what this equal sign is checking in JavaScript. You have to use other functions to check to see if the arrays have the same contents. But this right here is literally checking to see if they're the exact same object in memory, and they're not, and so that's why this one's false. But this one right here, those references, it's two different references to the exact same object in memory that's living in this one spot in like your RAM, like literally your RAM on the computer. There is an object that's created and sitting there, or an array, and this is saying both of those variables are referencing this same array in memory, this same like bit of like bits and ones and zeros that have been set to represent this array. Both of these references. All right, sorry about that, guys. That was a violent and abrupt ending to my explanation. My Wi-Fi just decided to turn off. So, okay, when did I cut out on you guys? You guys hear me? Can anyone hear me? Just speak up. Okay, I saw a thumbs up print out. Okay. All right. Okay, great. So, all right, that was pretty much the end of it too. I was just kind of diving into this like explanation of this, and this is honestly beyond the scope of what I was going to be doing originally with this coding challenge solution. But I like to do that. I like to dive in and explain little tangents that relate to the coding challenge, and it's just, this is all the stuff that we need you guys to know by the end of the course, and so we gotta cram it in there. So we'll be revisiting these concepts over and over again. So you'll become very comfortable with them. Okay. All right. Thanks, everyone. Let's look at the calendar real quick, so we can take a look at what we got going on today. All right. So you guys are purple. All right, so we have lunch, just a lot of project time pretty much today. We have your brown bag lecture that's at 6 o'clock. Ryan Hamblin will be doing that. Okay. All right, any questions about groups, project, anything like that? I guess just feel free to pop it in Slack, and then we'll go over it. Today's just kind of a project day. So like, your A days are a lot of like lectures and review and meetings and stuff like that, and then your B day is pretty much just like do the homework and do the project and get help. So today's like the much different pace from the A days. Okay. All right. Well, thanks, guys. I'll see you around.